Hello everybody, it is me Rajlashmi. Today we'll see a problem in artificial intelligence. So the problem is calculate the value of the at the root of the tree using alpha beta pruning algorithm. So we have to calculate the value of the root using alpha beta pruning algorithm. So we'll find out the value. We know this is a minimax tree. Okay, so it will have maximum node, minimum node, maximum node, and then these are leaf nodes. So we can find out the value of the root by taking the in each node we can find out the value. If it is a maximum level, we take the maximum values. Here if you see, we take 3 and 5, the maximum will be 5. Here the maximum will be 9. Here the maximum will be 2. Here the maximum will be 0. Next level it will be the minimum. So minimum means we have to take the minimum of this 5 and 9. So what is the minimum? Minimum will be 5, and then the maximum, here the minimum will be among 2 and 0, the minimum will be 0. Then I go to the next node, the maximum will be 5. So the value will be root be 5 only. So this is it's a game tree. So game tree can easily find out the value. But when we do the alpha beta pruning, so with alpha beta pruning we find out the root nodes which we can prune, that is we can cut or delete. Okay, we do not go through all the nodes. So that's why this alpha beta pruning algorithm is used. In this algorithm we have to find out the condition. So what is the value of alpha and what is value of beta? Alpha means the maximum value, beta means the minimum value. Okay, next you need to know the condition for pruning. So what is the condition for pruning? That is alpha should be greater than or equal to beta. So this is the condition for pruning. So you need to know all these. Okay, so for doing the pruning algorithm, we need to find out the value of alpha, beta, and then this is the condition for pruning. So first we can start, we initialize the node. So how it goes is, you travel from the root towards the left, reach the leaf node, then go to the from the left to the right, then again you have to go to the root, then again go to the this root, then again goes to the right. So this is how you will traverse. Now let us see how to do about this one. Okay, so here you initialize alpha as minus infinity and beta as infinity. Because alpha is a maximum value, initializing at minus infinity, beta is a minimum value, so initialize with beta as my infinity. Now propagate these values down. See, okay, we have come till this D node. So in D node we have two leaf nodes. Here we have the leaf nodes. It is 3 and 5. Now at each level we have to find out the we have to update the alpha or beta values. It is the maximum level. Okay, it is maximum nodes. Maximum level means we have to update the maximum node. So maximum node is what? Alpha is the maximum value. So you have to update alpha. First you have to check the value of alpha with the left values. Here it is 3 and minus anything which is the maximum. So 3 is the maximum. So first you will update as 3. Next you go to the right, here we have 5. So again you check the value of 3 or 5 which is the maximum. So 5 is maximum, so we will be updating alpha with 5. Okay, so you have updated this root. Next we go to the top. Here go to the B node. The B node we have to find that it is a minimum node, minimum level. So we have to update the beta value. First you update the alpha value when it is a maximum level, then you update the beta value when it is a minimum level. So beta you updated. So beta you update, you have to compare the value of beta with the current value of alpha and beta. Here we take the leaf nodes. Here you will take the current value of alpha and beta. So you have to check the value with alpha and beta. So alpha value is 5, beta is value infinity, and here beta value is infinity. So what is the minimum value? Minimum value will be 5. So you update this as 5. So you updated this beta as 5. Next you have to go to the right side, right part of this tree. So here you find that you have to copy these values copy these values down. So alpha becomes minus infinity, beta is 5. You have to update the current value down. Okay, then this node you have leaf nodes. So again you will find out that this is a maximum node, maximum level. So you'll update the value of alpha. So alpha here is minus infinity, and here the left side is 6, the value is 6. So we compare 6 with minus infinity, which is the maximum is 6. So we'll update this as 6. Next you have to come to the right node, but here you see that alpha is 6 and beta is 5. So this condition is reached, that is alpha is greater than equal to beta. So when alpha is greater than equal to beta, the pruning condition is reached. So this is the pruning condition. So this pruning condition is reached. When this condition is reached, then you need not traverse the later part of this node. Here we have traversed left, we have reached the root, we have to traverse right only. So this need not be traversed because this condition is reached. Hence we can prune this part. So this node will not traverse this node. Next you go to the top, you have to go to the next level, that is this root. So again we will visiting, first we will visit here, next we go down and then update it, then again we will visit the same node. So what we'll do, this is a minimum level means what, you will update the value of beta. So what values you will take, see beta value is 5 here. Now previous alpha and beta values are 6 and 5. So what is the minimum among 5, 6 and 5? The minimum value is 5. So beta continues to be 5 only. So alpha is minus empty. Okay, that is okay. Next you go to the top. After this one you reach the root node. So root node again it is a maximum level. So maximum level means what? We have to update the alpha value. So alpha value will be updated. So alpha value will update taking the current bit alpha and beta values. So among minus infinity and 5. So which is the maximum value? Maximum value is 5. So update this as 5. So you got the value is 5. Next we have to propagate the value down. So when you bring the value, when you go down, you have to bring the values down. So this is the node. Here we write alpha as 5 and beta as infinity. So we go down after this node gets traversed. So alpha is 5 and beta is infinity. Now we have reached the leaf node. So here we will find the maximum level only. So maximum level means we have to update the value of alpha. So alpha value will update using what? Using the leaf nodes. So here the value first to go to the left. So which is maximum 5 or 1? So maximum is 5. So leave it like that. So then 2. So 2 or 5 which is the maximum. So 5 only is maximum. So we leave it as such. Next we will propagate to the above node because we see this root node, C root. Here we find that is a minimum level. So in the minimum level we will update beta value. So beta value will be updated. Beta value is updated using the current alpha and beta value. So what is the minimum among infinity, 5 and infinity? So among 5 and infinity, the minimum value will be 5 only. So here beta will be 5. Now we have reached this condition that alpha is 5 and beta is also 5, which is alpha greater than equal to beta condition is reached, that is pruning condition is reached. Hence what we will do, we have traversed the left part, we have reached the root, and then this part need not be traversed, so we can prune this value has nothing to do with the result, so we can prune this. So alpha is 5 and beta is 5. Next we can even propagate this to top. Again maximum level, if you find already alpha is 5. Here the previous alpha and beta values will take no maximum value. Maximum value will be 5, 5 and 5. So the maximum value is 5 only. So the value of the root is hence the value at the root will be equal to 5. So this we can do without doing pruning itself, because you can find out by means of the game 2 can find min-max node, and we found the value is 5 with the root itself. But here we can, but in questions they will ask that which node will get pruned. They ask specifically by using alpha beta pruning. They will also ask questions like which node is pruned. or how many nodes are pruned, which will not be taken, like that they will ask. So we need to know this alpha beta pruning in order to solve such problems. Okay, I hope you are understand this problem. Thank you.